Rational expressions. Now you can add them, you can subtract them, you can multiply them, you can divide them. How about solving rational equations? That's what we'll see in section 8.6, solving rational equations. The objectives of this section: to solve rational equations, go figure, and to use rational equations to solve problems. Lesson vocabulary: rational equation, and an essential understanding of this section: to solve an equation containing rational expressions, first multiply each side by the least common denominator of the rational expression. Doing this, however, can introduce extraneous solutions. Sometimes you can solve a problem using a proportion. And there's a proportion. 2/3 equals x over 6. Remember, a proportion is just an equivalent statement between two ratios or two fractions. A rational equation contains at least one rational expression. You can simplify solving a rational equation if you first clear the equation of denominators. You can do this by multiplying the LCD of the rational expressions in the equation. Anytime you multiply each side of an equation by an algebraic expression, it is possible to introduce an extraneous solution. Recall that an extraneous solution is a solution of the derived equation, but not a solution of the original equation. You must check all solutions in the original equation to confirm that they are indeed solutions. Problem 1 does a great job of lining out what you should think on the left-hand side as you complete the process, and write what you see on the right. So here's the question: what are the solutions of the rational equation? And I'll let you read that rational equation. And now, well, problem 1 has this problem lined out very nicely, and I'd encourage you to pause and check that out. I'd like to work out this problem on the right-hand side, kind of explaining to you the way I complete the problem and what I would be thinking. So keep in mind that when solving a rational equation, the idea here is that we're trying to solve for x, find the value or values of x that make this equation true. We're going to need a common denominator. So perhaps that's what we should find first, and not just the common denominator on the left, but the common denominator of all of the fractions, or all of those rational expressions in this equation. So what we should do is factor that difference of squares denominator on the right-hand side. And remembering what we know about difference of squares, that factors pretty easily. The square root of x squared is x, so we place the x's there. The square root of 9 is 3. So if you recall, we write a plus 3 in one binomial and a minus 3 in the other. So there's the factored form of this denominator, and I realize I don't have a lot of room there. Thank you, Flipboard software. And that will equal what we have on the left. And now we seek out that least common denominator, which remember will be the least common multiple of all three of our denominators. I see an x minus 3, an x plus 3, and then an x minus 3 times x plus 3. So x minus 3 times x plus 3 will be our least common denominator. Knowing that, we now need to multiply every part of this equation, so both sides of the equation, by that least common denominator, x plus 3 times x minus 3. And I'm finding I need a little bit more elbow room, so I've copied some of this work to the next page, where here you can see in blue I've multiplied both sides of the expression by the least common denominator. So that least common denominator, all of this, needs distributed to both of these terms, and then something similar, actually something much more simple, will occur on the right-hand side here, where note x plus 3 and x minus 3 will cancel out. So on the right-hand side, we'll have 2 remaining. On the left, we'll have x plus 3 times x minus 3 times x over x minus 3 plus x plus 3 times x minus 3 times x over x plus 3. And on the right-hand side, we still have 2. Notice some things cancel. So on the left-hand side, we'll have x plus 3 times x. On the right-hand side here, x minus 3 times x. Distributing the x's to both terms in the binomial, in both of these situations, we'd arrive at x squared plus 3x on the left and x squared minus 3x on the right. And of course, equals 2. Combining like terms, dividing both sides by 2, and applying the square root. Keeping in mind there are 2 square roots of 1. Those are 1 and negative 1. But now we need to make sure that we haven't found any extraneous solutions by plugging in our answers, 1 and negative 1, and making sure they work in the original equation. First, plugging in 1 for x, reducing the right-hand side, finding a common denominator and adding our fractions on the left. And sure enough, negative 2/4 plus 1/4 does equal negative 1/4. And so this solution, positive 1, is not an extraneous solution. Time to check negative 1. And sure enough, that one works as well. So both of our solutions are not extraneous, and so they are true solutions to this equation. And here's a glimpse back at the book's method for solving this problem. Looking at it, it looks very similar to what I did. You may pause now if you'd like to look more carefully, but I'm going to move ahead. And Part B discusses another method for solving this equation using what's called a computer algebra system. That acronym CAS is pretty common in the math world, and basically it just gives you a very powerful calculator that will solve things for you, very much like Wolfram Alpha. We'll find solutions of equations, and also has a bunch of other advanced features. If you'd like, you may pause the video to learn more, but we're going to be moving on. And the moment you've been waiting for. The first opportunity to show that you have got it. Question 1 of 2. What is the solution of the rational equation shown here? Work carefully and make your selection from the choices below. And got it, question 2 of 2. What is the solution of the rational equation shown here? Work carefully and make your selection from the choices below.